This video is going to go over attributes of quadratic functions. So quadratic functions are just the U-shaped graphs, also called parabolas. This should not be that difficult to do. Let's just go ahead and get started. Number one here. The domain is asking you how far left, how far right this graph goes. So quadratics are always going to go left forever and right forever, as long as they don't have a restricted domain. So that means the domain of all of these graphs is going to be all real numbers. So I'm going to go ahead and fill that in on all of these. Even the ones that open downward like this, they're going to go left forever, right forever. So that means their domain is all reals. And even if they just give you the equation and they don't give you a graph, the domain is all real numbers. Okay. Next up is the range. You should know how to do this already, but if you don't, range is asking you how low it goes, how high it goes, and you're only allowed to look at these y values here. So the lowest it goes would be this point right here at -3, and the highest it goes would be up forever to positive infinity. So you use a bracket on the -3 because it actually hits that location. And then this goes up to positive infinity. And you always use a parentheses for the positive infinity or negative infinity. Okay, I'm not going to jump around anymore, so let's just focus on number one here. The vertex is the red dot, -2, -3. And the axis of symmetry is just the x value of your vertex. So you just go x equals -2. That's a vertical line at -2 that cuts the parabola in half. This vertex is a minimum. It's the lowest spot on the graph, and this parabola is opening up. Now, increase, decrease is a little different. You read it left to right like a book. So this green section of line here is decreasing. And when you answer this, you want to answer using your x values. So it's decreasing from an x value of -infinity, because remember it goes left forever. It's decreasing from -infinity until -2. And for increase, decrease, use parentheses on both. Don't use a bracket. Like that. Now, this blue section would be increasing. And again, you're answering using x values. It's increasing from this -2 spot all the way forever to the right, which would be positive infinity. Like that. Lastly is in behavior. In behavior, basically, you're just going to want to look at the arrows at the top or the bottom of these lines. So like this one has arrows going up and up. So here's how you do in behavior. You say as x goes to -infinity. That's like if you hop on the line at any spot and start going backwards, start going to the left. Then you just say, okay, well, what's my y value going to? This one, the arrow is going up, so y goes to positive infinity. Then the other one would be as x goes to positive infinity. So hop on the line and just start going to the right like normal. What's your arrow at the end doing? Well, your arrow at the end is going up. So your y values are going to positive infinity, like that. Okay, this next one. The range, the lowest that it goes is -infinity because of these arrows down here. The highest it goes would be 4. So my range is everything from -infinity to 4. And the 4 uses a bracket because it actually hits that location. This vertex is at 3, 4, which means my axis of symmetry is x equals the x value of my vertex, which is 3. This vertex is the highest point, which means it's a maximum, and this graph is opening downward. Increasing, this blue section of line here is increasing from left to right. Remember, I'm answering using x values, so it's increasing from negative infinity all the way until 3. This green section would start decreasing from an x value of 3 to an x value of positive infinity. And the end behavior, if I hop on this line and start going backwards, like to the left, the arrow at the end is going down. So as x goes to negative infinity, that's like saying if I go left, my y value is going down to negative infinity. Now the other one, as x goes to positive infinity, that's like hopping on the line and starting going to the right. My arrow at the end is going down, so my y value is going to negative infinity. And just one piece of information that you should know, when it comes to end behavior on a quadratic, your arrows are going to be going the same way. So your end behavior better be going the same way. Just something to think about. Okay, number 3 is where it gets a little trickier because they don't give you the graph. Well, they give you enough information. They give you your vertex, which is at -1, 1. So if you imagine a graph at -1, 1 is my vertex. And then this right here, this 1/4 is all the other information that you need, because since it's a positive number, it means this graph is going to be opening up. So like looking at number 4, since my a value is negative, my graph would be opening down. But we'll get to that one in a second. Okay, the range. Just by drawing this right here, I can tell the range, I can tell increase, decrease, I can tell the end behavior, I can tell everything that I need to know. Looks like I forgot axis of symmetry. X equals -1, the x value of my vertex. All right, the range. The lowest this guy goes is 1, y value of 1. Then it's going up forever to positive infinity. This vertex is a minimum, and this graph is opening upward. Okay, increasing. This green section of line right here is decreasing. So decreasing from an x value of negative infinity to -1. It's this section. All right, and then the other section that's still red here, that is increasing from an x value of -1 to positive infinity. Like that. The end behavior, if you go left, so as x goes to negative infinity, your y value, if you hop on this line and start going backwards on it, your arrow at the end is going up. So my y value is going to positive infinity. Then the other one, as x goes to positive infinity, that's hopping on the line and going to the right like normal. Your arrow at the end is going up. So y goes to positive infinity. Okay, number 4. First thing you should do is probably find your vertex. It's at 1, 3, which means my axis of symmetry is x equals 1. So 1, 3, we can call it here. The range of this is how low it goes, how high it goes. Well, this one is different. You have to look at your a value, -2. Since it's a negative number, it means this parabola is going to open down like this. So when you go to answer your range, the lowest it goes is the y value of negative infinity. The highest it goes would be this y value of 3. And it's a bracket on the 3. That vertex is maximum. It's the highest point on this graph. And this graph opens downward. Now, this first section of line here, this blue section, would be increasing from an x value of negative infinity to positive 1. So I'm increasing from negative infinity to 1. And then this green section here would be decreasing from an x value of 1 to positive infinity. And then the end behavior, both of these are going down at the end. So as x goes to negative infinity, that's hopping on the line and going left. My y value, my arrow at the end, is going down to negative infinity. And as x goes to positive infinity, your y value is going down to negative infinity, like that. All right, lastly, they want to kind of recap the last video, which is graphing a quadratic when it's in standard form. It's kind of difficult to do, so you want to stay fresh on it. Basically, you have to get your axis of symmetry first. The equation for that is x equals negative b over 2a. So identify your a, your b, and your c. So it would start out negative by default in my equation, and then my b value is negative 18 over 2 times my a value, which is negative 3. This negative on top is like a negative times negative makes a positive, so this part becomes positive 18 over 2 times negative 3 is negative 6. So my axis of symmetry is x equals negative 3, which means my vertex, the x value, is going to be negative 3. I have to go find the y value, though. The way you do this is you take the negative 3 and plug it in for these x's in your original equation. So it looks like this. Okay. Do a little bit of algebra and solve this out. Negative 3, the square happens first. So it becomes positive 9, like this. And when it gets multiplied by the negative 3, now it's negative 27. This part, negative 18 times negative 3 is a plus 54. Then the minus 20 at the end. So when it's all said and done, my y value, if you add this up, you'll get positive 7. So that means the y value of my vertex is positive 7, right here. My a value is negative 3. That's right here. Okay, now you have to kind of do your table using those parent function coordinates. And sorry, you're going to kind of write this equation in vertex form. So that would look like this. My a value was negative 3. Write it to where your vertex will work. So x, remember your x is lying, so you write plus 3 squared. And then plus 7, like that. Okay, go apply these transformations in a left to right order onto your table. So the first one would be the negative 3. That is timesing negative 3 on my y values. The next one would be this plus 3 on the x. Well, it's lying to you, so really do minus 3. And then the last one would be that plus 7 on your y values. Graph it using the outermost numbers as coordinates. So like my first coordinate that I'm going to put down is negative 4, 4. So it looks something like that. So that vertex is a maximum because it's the highest, and this graph is opening down.